In this question, we have that the center of mass is taken to be G, and Gx and Gy are taken as the principal axis. So we want to prove that the moment of inertia about Ox and Oy, okay, the moment of inertia about Ox and Oy is m alpha beta. They also have given you the moment of inertia of the lamina about Gx is mn alpha square and about Gy is mn beta square, which is parallel, and there is also one axis of moment of inertia at O, which is inclined at an angle 45 to OX. Then we have to prove that n minus 1 divided by m minus 1 is equal to beta square by alpha square. So here I'm taking the coordinate. Okay, so I'm taking the coordinate. Here I'm taking the coordinate as, here I'm taking an arbitrary particle P of mass small m whose coordinate with respect to Ox and Oy is Pxy, and with respect to Gx and Gy is nothing but it is Px dash y dash. So we take the coordinate of G with respect to Ox and Oy is given to be alpha beta. So we are taking alpha beta. Now we'll try to find the product of inertia summation m xy. But we know that we are translating this, so x will be given as x dash plus alpha and y will be given as y dash plus beta. So what will be your f star will be m x dash m x y. So we'll put the value of this, we'll get x dash plus alpha, y dash plus beta. So if we put this coordinate here, so we're putting this coordinate, we multiply this. Okay, we are going to, we have here, we are putting this f star, I'm going to find, or we are going to find f star. So f star is at, okay, f star is nothing but at, okay, f star is along the x or gx and gy axis. So we are taking this, so we multiply this one. Okay, so you multiply these two coordinates, so if you multiply this one, we get summation m, we are getting here summation m x dash y dash plus beta summation m x dash plus this m y dash plus alpha beta summation m. Now since we have taken this as the principal axis, so product of inertia should be 0. So we are taking this product of inertia to be 0. So this will be 0. Only this quantity is possible to be 0. This quantity can be 0. This quantity can be 0. But this quantity m alpha beta to summation m can never be 0. So we have this quantity is 0. So we get all these quantities. If this f star is 0, means these three quantities will be 0. So we get f star equal to alpha beta equal to summation m. So summation m is nothing but capital M. Okay, so we get here f star equal to alpha beta summation m. So m is nothing but capital M. So we get m alpha beta. So we want to find the product of inertia about Ox and Oy axis. That is nothing but m alpha beta. So we get here the product of inertia about Ox and Oy axis is given to be m alpha beta. In the similar manner, we will try to proceed further. Here we have this. Okay, we have this by, since A and B are the principal moment of inertia. Okay, this A by we will use the polar axis theorem. So we know the moment of inertia about Gx is mn alpha square, and about Gy is m small m beta square. So by using the polar axis theorem, we have A is equal to mn alpha square plus the mass and the mass of the lamina into the distance between the two axes, so that is beta, so beta square. In the same way, we'll apply the polar axis theorem here also. So moment of inertia about Gy is given to be m small m beta square plus mass of this lamina, so that is m, and the distance between these two axes is nothing but taken as alpha. So we have m alpha square. So that is about, this is A is about moment of inertia about Ox, and B is the moment of inertia about Oy. So since these are the principal moment of inertia, we have to take the product of inertia to be 0. So we have tan to theta is since product of inertia to be 0. So since these are the principal axis, we have in the coplanar distribution theory, we have already find how to find tan to theta. So tan to theta is equal to 2f b minus a. So here we are taking b minus a equal to 2f tan to theta. Okay, so f is what? F is taken to be 0 here. Okay, so f is 0. So you put here f to be 0. So if we put f0, we get here b minus a equal to 0. Okay, so let us put the value of b and a. So after putting the value of b and a, you try to simplify, and you'll get that beta squared by alpha squared is equal to n minus 1 by m minus 1. Thank you.